Hello everyone. So today we are going to explore a very important topic that is AI and quantum. So redefining the next era of computing. So these are the two of the most exciting take right now, that is AI, ML, and one more is deep learning. Okay. So first we will explain from the early AI machine learning to deep learning, and then we'll dive into the main topic, quantum computing. So today our agenda is we will briefly trace the journey of AI to machine learning to deep learning. Basically, how we got from early AI programs to powerful neural network of today. So first we will discuss about the brief introduction of AI, ML, deep learning. Then we will go into the main topic, that is quantum computing. First, clarify these words AI, ML, and deep learning. Okay. So people often use this term interchangeably, but they actually mean different things. So AI, that is called artificial intelligence, is broadest term. It's basically any technique that enable computers to mimic human intelligence. This includes everything from chess playing program to smart assistant. So you can think of it like this. Think of feeding a computer thousands of examples and it figures out patterns. For example, how does your email detect spam? Likely to the machine learning. So it has learned from lot of spam versus non-spam example to recognize the differences. So here ML is a part of AI, and then comes to deep learning, which is machine learning. Okay, so deep learning uses the networks of simulated layered neural networks that can learn very so many kind of patterns. Okay, so it's inspired by the human brain's network of neurons. So deep learning needs tons of data for training, but it's actually very powerful element. Okay, so you can imagine like a kind of nested circle, like AI is the big circle, ML is the circle inside it, and DL is inside ML. Now, so why everyone is talking about AI nowadays when actually AI has been around for decades? The answer is, we can say, like deep learning success. So in the past 15 to 20 years, deep learning has driven breakthroughs that seemed actually sci-fi before. Okay, so for example, image recognition. Computers actually can now recognize object or faces in photos even better than the humans in many cases. So we have kind of voice assistant like Siri, Alexa, that actually understand what we say mostly, and they are using deep neural networks. More recently, we have kind of chat GPT kind of thing, chatbots. We can say like not only chat GPT, DeepSeek. These are the chatbots are there. Okay, so that can hold conversation and create content. That's deep learning at work again. Okay, but these are the things that classic AI struggle with, but deep learning can make it very easily possible way. Okay, so there are some tasks still extremely hard for classical computers, but here AI grows, AI actually growing, and we run into computational roadblocks. So this is where quantum computing comes in the picture, and this can be a very next big revolution. So before jumping into directly quantum computing, so we have to understand some fundamental units of it. So first one is qubit. So qubit called quantum bit. So a regular bit in your computer or PC is binary. That's either 0 or 1. We can say like on or off. Nothing in between. But qubit, full form is quantum bit, can be 1, can be 0, or it can be like both 0 and 1 at the same time. For why it happened? Because due to a quantum phenomenon called superposition. Okay, so when bits are entangled, they are like twins. Okay, what happens to one instantly affect the other, no matter how far apart they are. So, as I said, superposition lets a qubit to be multiple state at once, giving the quantum computers a kind of built-in parallel for processing. And here, entanglement links qubits together so they work as a team. Okay, understand? So these are the magic ingredients that enable quantum computers to potentially solve certain problems much faster than classical computers. Now comes to quantum's potential and challenges ahead. So now let's talk about its potential, how potential it is. So if I can say how potential it is the potential is huge. So there are specific algorithms that give dramatic speed ups using a quantum approach. One famous algorithm is Shor's algorithm. Okay, so on a quantum computer, Shor's algorithm can factor very large number exponentially faster than the best classical algorithm. So if I say like RSA, so in security things like RSA or RSA encryption, which keeps your like online banking very secure, so relies on the fact that factoring big numbers is super slow classically, right? But in reality, quantum computers today have achieved some milestone. Okay, so for example, like Google's experiment where their quantum processor did a very specific task faster than a classical supercomputers. But actually those tasks are very kind of niche. So for practical everyday problems, classical computers still we can consider as a very supreme right now. But the quantum ones often produce noisy result, so we have to double check it, right? Now a quantum computer here, so AI plus quantum, we can apply it in a drug discovery. Okay, so a drug module would interact with a target protein much more accurately. So again, we can, thanks to superposition, a quantum computer can evaluate many ways a molecule might twist or bind all. Okay, so this means it can explore a huge range of potential drug candidates and their interaction quickly. Okay, so this is a application in drug discovery. So now comes to optimize the logistic beyond. So, as we know, in many cases, we use algorithms or machine learning to find a pretty good solution without checking everything. For instance, like Google Maps. So, Google Maps routing isn't checking every possible solution, right? Explicitly. So, it uses clever algorithms. Clever algorithm means it is a mix of so many algorithms and learn traffic data to quickly suggest an efficient route. In scheduling or supply chain also, AI might learn from past optimization, or use neural networks to guess good solution, and then we can fine tune them after that. So again, we have to say, like, thanks to superposition, a quantum computer can sort of evaluate many candidate solution at the same time. So there are concept called we can there is a in behind there is a concept is there, so we call which quantum d wave use. So here we use d wave, so that is the design specifically for the optimization problem. Okay, so it's like a gently shaking the system so it settle into a good solution, right? So the key point here is that quantum algorithm have shown for certain problems they can find better solution or achieve in a second, which might take classical algorithm much longer time for a larger problem. Now, so now comes to application in cryptography and finance. So here actually what I can say, so one of the most talk about implications of quantum computing is like encryption. So, like the larger number, like RSA encryption or computing discrete logs used in other crypto systems. So, these would take a classical computer millions of years to break by brute force, right? So, but a quantum computer run source algorithm could break those in maybe in minutes or hours if quantum computer is large enough. So that is the thing. So AI plus quantum in finance could lead like this, a real time risk management. So because calculation that took hours now, it may take seconds. Okay, so highly optimized investment strategies and even more powerful AI prediction, so model that keep learning on fresh data very quickly. So now, coming to the discussion part. So if you find the explanation and the slides are good, then please like my section, and I'm open to discussion for the any kind of clarification or questions. So you can comment, and I will reply as much as possible. And the summary I can say, like from the basic of AI ML DL to sort of very small part of quantum computing concept that I wanted to explain you. So yeah, so thank you everyone for listening me. If you like the video, please subscribe my channel. Thank you.